Hello everyone, I hope you're doing well. In this MTH 141 video, we're taking a look at question 1.2.1 from the textbook of First Course in Linear Algebra by Kuttler. You can find my notes for this course on my website, tutor.ca, where you can also find information about my private tutoring services. Okay, so let's take a look at the question, 1.2.1. Find the point x1, y1, which lies on both lines, x plus 3y equals 1, and 4x minus y equals 3. So in this section, this is the beginning of 1.2 from the textbook. You've learned about elementary operations, which are the operations that we can apply to a system of linear equations that don't change the solution set, but make it so that we can find the solution to the system in a, we can find it, period, algebraically, right? It's the way we find it without having to just graph everything and then see where they intersect. So the elementary operations are how we do that. Now, when you have just two equations and two unknowns, I'm going to show how to do this question in two different ways. You can do it with elementary operations, and it'll always work with elementary operations. The elementary operations are always going to be the way that will you can rely on them to get you the solution to the system. There is another way to do it with linear equations like this, which isn't graphing, which is also algebraic. It's a very similar method, but it's called the substitution method. Substitution method. Yes, I gotta make sure I spell things right. And that only works for this specific situation. Now there is, of course, the elimination method, which is with the elimination method, so I can't talk and write at the same time. And that is using our elementary operations. So first I'm going to show you how to do it with elementary operations, and then I'm going to show you substitution method. Again, substitution method only works for, well, technically it works for higher equations, like equations with more variables and more equations, but it would be much harder to figure out and to use in that case. So I'm going to say substitution method is only useful for a system with two equations in two unknowns, which is what we have. We have two equations, two unknowns. X and y are unknowns, are our unknowns. But so substitution method would work here. But let's take a look at elimination method first. Elimination method uses our elementary operations. So first, what I'm going to do is I'm going to write these equations on top of each other, sort of in like a nice list like this. So x plus 3y equals 1, right? 4x minus y equals 3. There's our two equations. And if you just want to recall quickly, what are our operations here? I'm going to quickly get them from my notes here. What are our elementary operations? Remember, a very important thing about elementary operations is that they do not change the solution set. That is the most important thing to understand from this section, is that when you do any of these elementary operations, they do not change the solution set of the system. So if I look over here, these are from my notes. If you want to get an access to these are from my notes. Of course, you can also find them in any linear algebra textbook, but particularly these ones are from my notes. So elementary operations are any of the three following operations that can be applied to a system of linear equations. So you can interchange the order in which the equations are listed. So I can switch the order of these two. Doesn't really seem useful yet, but it will be useful in later sections. So we're not really going to use that here. We can multiply an equation by a non-zero number. So I can multiply this equation by like 2. Let's say I want to multiply equation 1 by 2. And how I'd write that is I'd write it like this. I'd say equation 1 would be 2 times row 1, right? And so I would have a 2 here. So multiply all the coefficients by 2. So here there's a 1 in the front. So multiply that by 2, I get 2, 6, and 2. So this is a change I made, but I haven't changed the solution to the system. Okay, by doing this. And if you want an explanation as to why the elementary operations don't change the solution to the system, then I'm going to make another video explaining that, because that's a really, really important thing to understand. And there's a lengthy explanation in my notes on why this works. Okay, but we're not going to do that operation. We're not going to do 2 times that row, because that didn't really help us at all here. So I'm going to say 3, 1, bring that back to what it was before. And so now let's try using this third operation. Replace any equation with itself added to a multiple of another equation. So essentially, one thing that's useful here is what I can do is I can say, okay, well, I have 4 x's down here. Our goal in elimination method is to eliminate one of the variables. So let's say I want to eliminate x. So what I know is that I'm going to do, I have 4 x's down here, and I have 1 x up here, right? So if I want to eliminate, let's say I want to eliminate the 4x here. Oops, I erased the little bracket on the 4, or a little right side on the 4, on the x, I mean. So if I want to eliminate this 4 right here, I'm going to do I'm going to write it like this. Row 2, so the row 2, is going to become, okay, well, I usually write it with an arrow. Row 2 is going to become row 2 minus 4 times row 1. Okay, so let me make sure that this matches here. I can replace any equation with itself added to a multiple of another equation. I'm replacing row 2 with itself added to negative 4 times row 1. So that works. And let's see exactly how that works, though. Let's do it here. So our first equation, so this, usually actually the notation used here is that I would say this is a system right there. I'd put it with brackets like that. And the next set, after I use this operation, is going to be x plus 3y equals 1. Row 1 didn't change. And now row 2. So row 2 is going to become row 2. It's going to be 4x minus y. That's row 2. Minus 4 times row 1. X plus 3y. Equals, and don't forget to do the same thing on the other side. Row 2 was just 3 on the other side, on the right side of the equation. Minus 4 times 1. That's what's there in row 1. Okay, so this forms a system as well. It has the same solutions as this system. That's the point, right? Let's simplify the bottom here a little bit. So the top stays the same. X plus 3y equals 1. And on the bottom here, we have 4x minus y minus 4x minus 12y equals 3 minus 4 is negative 1. So just distributed the negative 4 in there a little bit. Well, one thing to notice is that 4x and negative 4x cancel. Negative y and negative 12y are going to combine into negative 13y equals negative 1. So sorry, let me write this a little bit better. That forms a system. So the top is going to stay the same, x plus 3y equals 1. And yeah, and so our next equation now is going to be negative 13y equals negative 1. And look at that. We can essentially get from this last equation tells us that y equals 1/13. That's good to know, because now I can go to this equation, right? So, in fact, I'm going to write it as another step in the system. These two equations form a system. X plus 3y equals 1, and y equals 1/13, right? And so now, if I want to find x, right? So I know the y value of our solution. I want to find the x value. Well, I can just go to this equation and sub it in, right? X plus 3y equals 1. Well, that'll become x plus 3/13 equals 1, or maybe I'll write it nicer, 3 times 1/13. And so finally, x is going to equal 1 minus 3/13, which is approximately, let's take a look. What's 1 minus 3/13? I mean, we could do it in fractions and everything like that, but let's just take a look at what our calculator gives us. 3/13 is, well, 10/13. That makes sense. So 10/13. And there we go. That's our solution. So if I write it out nicely here, our solution, xy to the system, is 10/13, 1/13. And so that's the point that lays on both lines here. Now that was the elimination method. Let's take a look at the substitution method. It's a little faster for this specific situation that we have here. Okay, so again, elimination method is like this. Elimination method uses our elementary operations to solve the system using them. Now, it is the best to use the elementary operations in a question like this, because again, substitution method is only actually useful for a situation like this. Elimination method is how we actually solve the systems, and especially systems of any higher number of variables and equations, which is what you're going to learn how to do in this chapter, which is solve a system of any number of equations and any number of variables. Anyways, substitution method. Let's get to that. Substitution method. Substitution method is essentially just a trick to figure out how to do it for these specific questions. So let me go back here to the actual questions. X plus 3y equals 1. X plus 3y equals 1. And the other one was 4x minus y equals 3. Equals 3. What I can do is I can rearrange both of these and put them into y equals mx plus b. Right? So again, these form a system. I'll put it in green so you can see what these form a system. And that bracket, that's what I'm using to show that these form a system. The bracket just means form a system. So if I arrange both of these into y equals mx plus b, it's going to look like this. And so, of course, rearranging equations doesn't change any kind of solutions. Right? So here, let's say that. So in this in slope-intercept form is going to be y equals a negative a third x plus a third. Okay, so you take a moment to pause if you're having trouble seeing that. Just pause and work it out yourself there. But you'll see it's negative 1/3 x plus a third. And then this one down here is going to be y equals 4x minus 3. Okay, so the solution set of this system is the same as the solution set of this system. Of course, because I just rearranged the equations. Rearranging equations, again, doesn't change anything. So now what I can see is that, well, y equals this and y equals this, right? Y equals two things. If the y value of our solution is equal to this expression, and the y value of our solution is also equal to this expression, what that tells me is that this box must be equal to this box, right? Because they're the same thing. They're both equal to the y value of our solution. So what I can get from this is that 4x minus 3 equals negative 1/3 x plus 1/3. And now we can solve this because it's one equation, one unknown. And we can just solve this for x here. So it's going to be 4x plus a third. X equals 1/3 plus 3. 4 plus a third. Well, 4 is the same thing. So 4 is 4 over 1, which is the same thing as 12 over 3. So it's going to be 13 over 3x equals, now 1/3 plus a third. Well, 3 is 3 over 1, which is the same as 9 over 3. So 10 over 3. 10 over 3, right? And so this tells us that x equals 10 over 13. And look at our solution from up here. X was 10 over 13. Yeah, we got the same number. 10 over 13. We know that's the answer. So there's our x value. Now, how do we find our y value? We can go back to either one of these equations and just plug x in. We know x is 10 over 13. So we can go back to either one of these equations and just plug it in. So I'm going to choose the second one here. So y equals 4 times 10 over 13 minus 3. Y equals, now, what's 4 times 10 over 3? Well, it's 40 over 13. 40 over 13 minus 3. Okay, and what's that? Well, 40 over 13. Okay, well, let's start with here. 3 over 1. 3 times 13 is 39. 26, 39, yeah. So multiply by 3, so 39 over 13. So 40 minus 39 over 13 is 1 over 13. And if you look back at our solution, the y value is 1 over 13. And there we go. We get the same answer. xy equals 10 over 13, 1 over 13. And that's the point which lays on both lines through the substitution method. Substitution method was a little bit shorter here. It's a good system to use instead of having to think about the elementary operations. You use it a lot in calculus as well if you have a system of two equations, two unknowns that you need to solve quickly, like some optimization problem or something like that. So there's your two methods to solve the system. Now, from now on, I'm just going to use elimination method, but I thought it would be good to mention substitution method, which is, again, only works for... It works for other methods, I should be clear. It works for other systems, like more equations, more unknowns. It would work. It would just be a lot more complicated to figure out how to do it. The thinking about, like, how do you substitute things into each other is a lot harder to do when you have a higher number of equations and higher number of unknowns. So for those situations, just always stick with the elimination method. And essentially for the rest of the course, we'll be sticking with elimination method. Okay, well, that's everything. That's the solution to the system. I hope it was helpful. Thank you so much for watching. Have a nice day.